Hello student, we will discuss about the subject strength of material or mechanics of solid. In the subject of strength of material, we study about the deformable body. Deformable body means when we apply a force on a body, then the body will change their shape. We apply a force on a body, then stress will be produced on body. Stress denoted by sigma. Stress equal to internal resisting force divided by cross sectional area. Suppose we take an example. This is a bar having a length L. We apply a tensile force P. Due to this force, the body will be elongate. The body will be elongate and the change in length will be denoted by del L. The body formed by the molecular attraction force. When we apply a force, then the particle resists this force. This force is called as a internal resisting force and the cross sectional area is this. So this one called as a stress and the unit of the stress is Newton per meter square. The type of stress can be classified into two types. First one is a direct stress and second one is a indirect stress. And direct stress further classified into three part: tensile stress, compressive stress and shear stress. And indirect stress classified into two part: bending stress and torsional stress. Direct stress means when we apply a force on a body along the longitudinal axis, then the deformation produced along the longitudinal axis, so called this one is a direct stress. And second one is a indirect stress in which loading is indirect, means not a longitudinal axis. Direct stress, then we study about a tensile stress if the nature of the force is a tensile. Suppose this one is a bar, we apply a tensile force. Due to this force, the body will be elongate. This called as a tensile stress. Internal resisting force divided by cross sectional area, and the internal resisting force is a applied force. And second one is a indirect stress. Suppose this one is a bar, we apply a compressive force. Due to this force, the length of the body will be decreased. This called as a compressive stress and load upon area. And third one is a shear stress, in which we apply a force tangential direction to the surface, so the body will be deflect. This called as a shear stress. And another one is a indirect stress, in which force will be applied in an indirect loading condition. Then further classify into two part: bending stress and torsional stress. First we define a bending stress. Suppose this one is a bar having a length L and supported by a knife edge support. We apply a load P. Due to this force, the body will be deflect. This one is a neutral axis at which stress will be 0. Bending stress denoted, the formula of bending stress M by I equal to sigma by Y equal to E by R. M is the bending moment, I is the moment of inertia, sigma is the bending stress, Y is the distance from neutral axis, E is the Young modulus and R is the radius of curvature. Then second one is a torsional stress. Suppose we take a bar, one end rigidly fixed and we apply a turning moment. This one is a longitudinal axis. The body rotate about their axis, some with angle theta. The formula generally we use T by J, C theta by L equal to tau by R. T is a turning moment, J is a polar moment of inertia, C is a modulus of rigidity, theta is the angle of twist, and length of the bar, tau is a shear stress, and R is a radius of curvature. This is a simple stress and the classification of the stress is over. Then we study about strain. Strain means the deformation produced by stress is known as strain. Suppose we take an example. This is a bar. We apply a force P, tensile force, and the L is the length of bar. Due to this force, the length will be increased that way. And strain denoted by epsilon equal to change in length upon original length, and this is a unitless quantity. So the overall topic will be concluded, stress and strain. Thank you, students.